So in this video we're going to use completing the square in order to put an integral into a form that we can integrate using the arctan function. So here I have a constant over a second degree polynomial, which tells me I might be able to complete the square as a valid technique to get it into the form 1 over a squared plus u squared. So I'm going to go ahead and rewrite the integral. We have the integral of 1 over x squared minus 2x plus 10 dx, and I'm leaving myself some extra space here and here on purpose. And so remember, to complete the square on a quadratic, we need first to identify whether the leading coefficient is 1 or not. To complete the square requires the leading coefficient be a positive 1. I'll look at the coefficient on the x squared term. I see it's a 1, which tells me I can complete the square. To complete the square, we know that we take the linear coefficient, the coefficient on the x to the first term, in this case negative 2. We take half of it, and then we square it. So if we do that, that tells us we're going to be squaring a negative 1, which will give us a positive 1. So I take the 1 and I add the 1 to the x squared minus 2x, but I can't arbitrarily add a 1. So I'm also going to subtract 1 at the same time, because 1 minus 1 is 0. I've changed how the denominator looks, but the denominator is equivalent to what it was before. Now I can go ahead and rewrite the denominator so it starts to look like the a squared plus u squared form. So because I completed a square on these terms, I do x, and then what did I square? I squared a minus 1, so it's going to be minus 1 getting squared. If I square this binomial out, I should get the x squared minus 2x plus 1 back. Plus, here I have a 10 minus 1 is 9, and this is dx. And now I can start to get it into this form. What I want to recognize is if I do the substitution u equals x minus 1, I can really start to get it into the a squared plus u squared form. So I'm going to have a 1 over. I'm going to let u equal x minus 1 right here. If I do that, then du dx, the x, taking the derivative with both sides with respect to x, is going to give me du dx equals 1, which means du equals dx by algebra. So I'm going to do the substitution u equals x minus 1, which will give me a u squared, plus 9 can be rewritten as 3 squared, and dx can be replaced with du from the work that we just did. And notice now I basically have the a squared plus u squared form. I could run with what I have, because the order of addition doesn't matter. We could easily rewrite this as 1 over 3 squared plus u squared du using the commutative property of addition. And now I have exactly the form 1 over a squared plus u squared, where in this case a is equal to 3, so I can just apply the formula directly. 1 over a is going to be 1 over 3 times the arctan of u over a, but a is equal to 3, plus a constant of integration, and then substitute back in for our u equals x minus 1, so we're going to rewrite this as 1/3 arctan of x minus 1 all over 3 plus a constant of integration.